Hi, in this video we're going to have a look at finding a minimum spanning tree from a table, and for this we use Prim's algorithm. The algorithm runs in exactly the same way that it does when we're using a graph. Just it can be a little bit tricky when you're using a table, just to get your head around what's going on. So I've got a little tip over here for you. If you draw the spanning tree as you go, it will help make sense of the algorithm. So we choose a starting vertex, and then delete all the elements in that vertex's row and highlight its column. So I'm going to highlight column, and I'm going to start with X over here, so we'll highlight column X, and that means that I must now delete row X. So that's now gone. And now I neglect anything that's been deleted, and I'm going to scan all of the highlighted columns. So I've only got one highlighted column at the moment, that's column X, and I'm going to scan that for the lowest available element and circle that element. So if I look down here, the lowest element is going to be this 12 here. Oops. Okay, so I'm going to highlight the 12, and I'm just going to make a note that I've gone X, U, and that's 12. And over here I'm going to mark X and U, and that's connected together. Okay, so that's the first part of my tree. I'm now going to delete the circled elements row and highlight its column. So I'm in row U over here, so I'm going to delete the rest of row U, and I'm going to highlight the column U. And now I'm going to scan X, the X column and the U column for the lowest weighted edge. So as you can see, that's going to be Y13. So just to give you an idea of what's going on here, we've got this start of our tree here, and we can only draw edges going from X or from U, and that's why we're scanning just these two columns. So I've chosen Y, which is 13 away from U, so I can draw that in. Doesn't matter where I draw it. So that's going to be Y there, and I've chosen U, Y, which is 13. Okay, so I can now delete the rest of row Y, and I'm going to highlight the column Y over here, because I can now choose, I can draw my next edge from either X, U or Y. U, X and Y. Okay, so I now scan to find which is the lowest weighted edge, and I can see that UW is 14. So we'll make a note of that. UW is 14. So I'm going to draw W over here, and that had a weight of 14. I can now delete the rest of row W, and now I'm able to choose an edge that comes from W as well. So that's why I'm going to highlight that, so I know that I can choose from there as well. I'm now going to scan the rest of them, looking for the lowest weighted edge, and that's going to be 17, and that's YZ. So from Y I'm going to draw an edge that goes to Z, and I'm going to make a note over here. I'm just going to move this along a little bit. And I've got Y, Z, and that was 17. Okay, so I can now delete the rest of row Z. I can highlight Z because I can now draw an edge from it. So I should only have one edge left, and that's going to be, one vertex left, and that's going to be V. And I'm looking for the shortest way that I can get to V, and that's going to be from W. And that has a length of 21. So VW with a weight of 21, and I'll just mark V over here. Okay, and there you go. I'm now going to write down my minimum, and I need to sum all of these together. So that's going to be 10, 16, 18, And that's going to be 78. So I have a minimum weight of 78 for the spanning tree. Okay, I hope you found that useful. I'll see you again next time.